Hey guys, so in this video we are going to be making a multiple game object save and load system. We are going to be saving the transformation and rotation as well as saving multiple state of the game object. So this is what we'll be making. So this is a very simple scene. We can instantiate any cube, and if we hit R, then we are in rotate mode. So we can see we can rotate in any axis we want, and if we hit R again, we are going to be on drag mode. So we can like place the game object wherever we want. Then we can play, let's say place another game object. So let's say sphere. I'm going to go in drag mode. I'm going to place it here. I'm going to place a cube here. I'm going to go in rotate mode. I'm going to like rotate it like this. Now, when I hit save and quit, it is going to save the data inside our save folder as inside a JSON file. So this is what our data is going to look like. So basically, this is what our data is going to look like. So is this save JSON 2 doesn't have actually any data. So let's go over save JSON 1. Sorry, yeah. Actually, I think there's something wrong with the save. So here is the data, but for some reason the formatting is going up. So yeah, now you should be seeing. So we are going to save the name, the position, the rotation, and if we load the game again, so let's say we load it, it is going to keep all the game object in the current position that we saved with the rotation and their transform. So let's make this. To make this, let's open up our Unity project. So Unity. Now let's create a new project. We can call this whatever you like. If you want, you can use the HDRP plugin. It's going to make it look a lot better, but I'm going to keep it the way it is, just 3D plugin, and I'm going to call it, let's say, save system, and let's hit create. So our project should be creating right now. No need for this. Let's just do this real quick. All right, that's close enough. Sorry about the background noise. I can't do anything about that. So first, go to your package manager, and then in Unity registry, search input, because that's going to be really important. Install it. So input system should install really quick. Yes, restart the editor. Second thing, while this is restarting, this is the script I'm going to be using for the FreeCam. So basically, this is a FreeCam script that is available on GitHub. All the credits goes to the developer of this script. So just take it, copy it, entire script, and like paste it in your project. I'll leave a link of the script in the video description, but yeah, you can use it. This is a really good script, and credit goes to this guy right here. So our package has been installed. Now the first thing is we're going to be doing is we're going to create the FreeCam, adding the FreeCam script to our camera. So let's create a folder called scripts, and inside the scripts we're going to be adding our C# script for FreeCam. Let's open that up in VS Code. All right. Yep. So let's control all and then paste it. The only thing we're going to be changing is the R key, because we are going to be using the R key to toggle between drag and rotate. So instead of R, you can just put T. So we are not using the T key, so you can just paste it here, and that's good enough for our FreeCam script. So it is going to compile. Yeah, no problem. Now let's add a 3D plane. So 3D plane, all right, should look uh, nice here. So let's just try to, yeah, it kind of looks good. Yeah. Now I'm going to hit R and I'm going to scale it a bit. And I'm probably going to pan it to the left a bit. Hit W to go back to transform mode. Alright. Now that it's there, let's quickly create a material folder. So folder materials. Inside the materials folder, let's create a material for a plane. And the color is going to be, let's say, a bit of metallic color. So paste that there, and then we can give the metallic smoothness to, let's say, 0.7 or point, yeah, let's give it 0.6, or should we increase it to like fully 1? Nah, let's give it 0.6. That looks good. And what else? We do not need emission, so yeah, that should look good enough for our basic plane. And now in the main camera, hit Ctrl Shift F. This will lock this view we have currently to our main camera. Now go back to the scripts folder and drag the FreeCam script to our main. Now our main camera should have a free movement. As you can see, our main camera has free movement. Now go back and create scripts for, let's call it spawn GameObjects. So we are going to be using this script. Sorry, I misspelled it. So it's going to be spawn GameObjects. Yeah. Now open that script in VS Code. Since we have to match it, so it's going to be spawn GameObjects. The same, it has to match this name basically. Now the first thing we're going to need is Unity Engine. System collection is already there. We need Unity Engine input. So basically copy it. My code editor doesn't have basically auto suggestion, and put. I'm not using Visual Studio because it's going to take too much RAM on my PC. That's why I'm using VS Code. And then we need the UI system, so using Unity Engine. So using Unity Engine .ui. And the last thing we need is we need the TM Pro system, because we are going to be using a TM Pro plugin for our buttons. So using TM Pro. And that's it. That's all we need. Now keep the update and start as it is right now. It's fine. Let's get started. So first of all, we need a serialized field. So it's not showing any like suggestion for the serialized field. All right, doesn't matter. Serialized field. And the serialized field is going to be basically so public game object. So public game, and it's going to be our cube prefab. So this is game object, and it's going to be cube prefab. Now we haven't created the cube prefab yet, but we are going to make it shortly, so don't worry about it. And then we can create another prefab called sphere prefab. So cube prefab and sphere prefab will basically contain our data for the cube and sphere. Now we can say private camera we can say private camera and cam. So this is going to basically be our main camera. Alright, so we have imported our basically not imported, initialized. Now what can we do? We can say a private string, so it's private string, and this is going to be object to instantiate, or basically whichever object we are going to be instantiating. So let's just call it object to instantiate. Object to instantiate, and we can basically initialize this as nothing at the moment, and then we can go inside our basically start method, and we can say cam is equal to camera dot main. So basically we are getting a reference to main camera, so camera dot main. Okay, this is going to be a problem, but bear with it. So yeah, we got reference to our camera. Next thing we need is to create a function, and that function is going to be void. Let's see, what can we say? So basically anywhere in our 3D space we got a error. Where is the error? The error is in 31 number line. That's not an issue. So basically wherever in our 3D space we are going to click, in that point we are going to instantiate a object. So to do that, let's call spawn at mouse click or something like that. At mouse click. So wherever we're going to click at our 3D space, that's where we're going to instantiate a game object. So if mouse dot current, so basically we are getting the current, and then left button. So left button, if you don't know, is the fire one. So you can also say like fire on as well, and was pressed this frame. So basically if the button was clicked on this frame, so basically whenever running a game object, it's going to be running on frames, basically like it's a collection of frames, and when you press the button, if it's pressed on that frame, then it's going to go inside this function. And inside here we can say ray. Basically we're going to use raycast. So cam dot screen point to ray, and we're going to say mouse dot current dot position dot, what do we need? We need to read the value of that position, so we can just say value. So that's pretty much it. Now did I misspell anything? I should not. Raycast, yeah, raycast hit, we can call it hit. And if physics dot raycast is equal to the ray out, and the out is going to be basically our hit. If it's similar to that, then we can say game object, we can call it basically cube. Actually no, we have to do something else before that. First of all, because we have two different game objects, we have to like consider like which game object to instantiate, and to do that we can basically say if our object to instantiate is equal to cube, then we can say game object cube is equal to instantiate auto suggestion would have been so much better now. Instantiate, so cube prefab and we're going to instantiate using new vector 3. Okay, it did not import, that's good. Sometimes it's going to import the numeric, that is going to throw an error, so you want to watch out for that. And hit dot point dot x, and then we're going to have the hit dot point dot y, but we have to add our game object. So our cube prefab dot its transform, and let's say in z-axis, no, in y-axis, because we're adding for y, so it's position dot y. That's it, and I'm going to explain why you need that. And next is a dot point dot z. Yeah, that's pretty much it. And then we need quaternion dot identity. So why did we add this extra line? Like, why are we adding the cubes like basic point in y-axis with the cubes transform.y? So basically, anytime we yeah, it is going to get import a numeric system, you just have to remove this. That's the error. So the reason it's throwing the error is basically because, let's say I instantiate a cube, right? It is going to be instantiated in between, so that's not what we want. We do not want the cube to be instantiated in between. So to avoid that, what we're adding, like we're adding wherever we set the cube's position. So let's say we save it here. Obviously, if we drag it in our project, it is going to still have this y, and every time we instantiate, it is going to add its 0 location with this y. So that's why we are adding that extra value. But if you want, you do not need to add that. All right, so we have the cube value. Now we need cube dot name. So we need to give our cube a unique name, and the reason, because if we take a look at the save data, we need basically a unique name to differentiate between different cubes. So if we have like 4 or 5 cube and all of them have like same name cube, then it's not going to be able to save the data. That's why we need to add a unique identifier for each cube. So that's really easy actually. So you can say cube under slash plus system dot GUID. I'm hoping I'm pronouncing that right, but new GUID ID actually, and we can basically cast that to string. So string, that's it. And that's basically going to save our key with a new name, and after that we can say object to instantiate is equal to null, because already instantiated object, we no longer need to instantiate it again. Then copy this line and basically say else if it has sphere. So if it has sphere, just do this. So wherever there is a cube, so basically like there's a cube here, there's a cube here, sphere, that's it. That's all you have to change. And if I'm not mistaken, that's pretty much it. Oh, one more thing actually. So we have created a function to basically spawn at mouse point, but we also need a function that is going to be attached to our button, so UI button. So for that we need a public function, public void on click. So public void on clicked, and what we can do is say GameObject. We can say GameObject and button. Now inside, what the hell just happened, sorry. And inside we can select object to instantiate is equal to button dot name. That's it. That's all we have to do. Now we can basically call this inside our update method and done. So yeah, that's pretty much it for our spawn game object. we don't have anything else here. So let's see, we have spawned a game object. Now let's quickly create our UI. Let's create a canvas. Nice, we have a canvas. Now let's create button. So UI, and under that let's create button. So button text mesh pro, import text mesh essential, and then import text mesh example and extras. Done. Now we have a button. On the button, what you want to do is click on this and then hold Alt button. So if you hold the Alt button, it's going to anchor it to whichever point you want. I want to anchor it to the left top corner of the screen, so I'm going to hit this part. But you have to hold the Alt button for that. Now let's quickly bring it here. Let's give the button a quick, let's say I like kind of this color, we call it cube, and inside this we can say cube. Done. That's how easy it is. And similarly we are going to basically control D to basically duplicate sphere, and one more thing, it's better to keep it all small letters, so not big capital letter. Alright, sphere, I'm going to drag it a bit lower, and I'm going to give it a unique color, let's say yellow. Yeah, works I guess. Now we need to create our let's create our drag game object first, because those are the two main part. After that, rest is pretty much simple. So let's go to script, let's call drag game objects. So drag game objects, let's open up that script, and all we need to import is Unity UI. What else do we need? We need the vector, so private vector 3 is going to import numerics. We can remove that later. M offset, so M offset. And what do we need? We need our z coordinates, so private float z coord, and we need our, I guess we do need a game manager for that, but well, there are some data we want to be saving in game manager, but do we need it right now? I think actually, yeah, let's work on game manager first, because there are quite a lot of things we need to save in game manager. This is going to give us an error. Remove that. It's going to resolve it. First, let's create game manager. The reason I'm creating game manager, because a lot of things is actually going to be in the game manager. So first of all, Unity engine, let's copy it. We do need UI, we do need input system, so, and what else do we need? We need system IO, I think. Yeah, using, yeah, basically system IO is when we're going to work on the save manager, but right now it's not actually needed that much. So first thing first, we need to basically create public game object, and it's going to be an array, because we are going to be storing multiple game object in there, and it's going to store the spawned game object. So whatever game object we have already spawned in our scene, it is going to be stored here. Next we need a public variable called boolean type that is going to be r enable, and r enable is basically going to be for our r button. So if we are in rotate mode, it is going to be yes, and if it is going to be true, and if it's not in rotate mode, it is going to be false. So that's why we are saying it's r enable, because if our r button has been enabled. And then the next thing we need is a reference to our public spawn game object. So basically whatever we made earlier, so we need a reference to this script basically. So if I take it public spawn and spawn game objects, now it doesn't actually have to be public, you can just say like spawn game object, but yeah, let's keep it. So next we need a public string. So public string, and it is basically going to be selected game object, selected game object name, or we can basically say selected object name to keep it simple. And basically a selected object is going to do is whichever game object we click on, it is going to take that game object name and save it. That's it. That's the entire function. And similarly private, it is going to have a game object, and it is going to be selected game object. So get object, so whatever object we select basically. Now we need two things. We need a serialized field, I really miss auto suggestion. So public game object drag. Now this drag, wait, let me just make one for rotate as well. We haven't made these two yet, so let's make it. UI, let's say I'm going to hit a button, let's call it drag. Let's give it a color, nice green color, and the inside is going to be drag mode, and the color is going to be white. No, let's give it black. Now I'm going to copy this, it's going to be rotate. Inside I'm going to say rotate mode, and this color is going to be white because this will be red. Now hold drag and rotate both and just stretch it out. Next hit the center, and this time we are going to align this with top middle. So hit alt and hit the top middle. It is going to align it to the top middle, and then just down it. So that's the entire reason we have this two field for drag and rotate. Now let's see what can we do in our start method. So in our start method, the first thing we can do is spawn game objects is equal to find type of. So find object type of, no, not type of, find object of type, sorry, yeah, find object of type. And basically this is going to be finding our spawn manager. So spawn game object. So basically what this actually doing is basically finding this script, nothing more. All right, okay, there is an error on line 21. So line 21 there is an error, and it says spawn game object. Oh, sorry. The reason it says that it's going to be spawn game object, not spawn. That's why the error. No worries. Now let's quickly disable the rotate set active. So at the start, we are going to be disabling both our rotate and our drag. So that's why we are saying rotate and drag is equal to false. We don't want to show it. Unless you hit the R button, we do not want to show this. In the update method, let's say if input dot get key down key code dot R. So if our key code is R, then now one thing, key down only takes one frame, but if you just use key, it's going to taking a lot of frame, and that's why it is going to be switching between enable true or false multiple times. But if you just take key down, it's only going to switch once every time you hit it. So that's the important thing to note. Do not use key, just do not use get key, use get key down or like get key in this frame, something like that. All right. Now if we hit the R button, we are going to say R enable is going to be equal to whatever it's already not. So R enable this. So basically if it's false, it's going to be true. If it's true, it is going to be false. So that's the entire logic there. And if R enable is true, so if R enable is equal to true, so that means our rotation is actually active at the moment. Then spawned uh, spawn game object is going to be game object. Actually, I'm just going to take it. There is going to be an error. Game object dot let's say find game objects. Game objects with what we can find it with name, or we can find with the tag. With let's use tag. We can easily make a tag. So let's call the tag spawn. Actually, yeah, we can work on that later. Not very important at the moment. So for each, basically, so for each game object, I'm again going to paste this game object is spawned game object. So did we say spawn whatever this is in spawn game object? So yeah, if it's in our spawn game object, we're going to be checking the name. So spawn game object basically dot name is equal to selected object name. If it's equal to selected object name, in that case we can say selected object dot get component. See, yeah, I'm even misspelling that. Get component, we are going to get a render component. So just get the renderer, renderer component. Sorry. So you are taking the render component, and then you want to take the materials, material.color, and material.color is going to be color.red, because we are rotation, and in rotation we are basically in red color. So that's why we are saying that. And because it doesn't matter, this error is because it imported the drawing, and that's my fault, not your. My VS Code is actually acting up a little. Then we are going to say spawned object, actually, sorry. Spawned object is going to be equal to actually no, we a bit of error actually, so do we to go that round? Mm, actually, yeah, wait, if we use spawn game object, then there's going to be a problem. Alright, let's do it just. So spawn game object is going to take get component, and the component we want to use we want to take in is basically track game object. We want to take this component and we want to enable, yeah, we want to set the enable to false. The reason we're setting the enable to false is because once we're in let's say rotation mode, we don't want the drag script to mess up our rotation script, so that's why we're setting the drag script to false. And once we're going to be in drag mode, we are going to set the rotation script to false. So let's quickly create a rotation script, otherwise we're going to get an error, assembly error. So rotation, what can we say, let's say rotate game object. Rotate game objects. So basically we are going to set this, so copy this, and we are going to be setting this to true because we want this to be active, so true. So if like our object name is equal to selected object name, basically if rotate is enabled, then it is going to do all this. If rotate is not enabled, it is going to do all that. Yeah. Now what we can basically do is we can set the rotate dot set active to true. Basically this, we are setting the rotate to true, and we are going to set the drag to false. And if basically enable is not equal to true, so if it's not true, then just take all this, paste it here, instead of if, say it else. Don't need those. Everything is going to be just same, but instead of drag being false, is drag is going to be true, and instead of rotation being true, it is going to be false. Similarly, drag is set to be false, and here rotation is going to be set to be false. Yeah, that's all you have to do. So we are enabling the drag script, and we are going to change the methodological color to green because our drag script is green. Okay, hope all that makes sense. If not, it's actually not that hard. I'll give an overview after we are done with it. Next thing we actually do need to do is basically we need to actually get a reference to like when you are hitting the button or the fire on button. To do that, I can basically do like if input please don't, yeah, so input dot get mouse button 0, so down, and it's going to be 0. If I just say to get mouse button, it's going to keep taking the input over and over and again, but if I just use the down, then it's only going to take the input once. So that's the difference between down and the normal button. And basically where is the spawn manager, we actually do need that script. We can save quite a time writing, so basically like take all this, we are going to be reusing it anyway. So here. Let's paste that, but this time it is going to be, actually no, it's going to be pretty much the same. Current position value, yeah, actually no, it's going to be a bit different because we don't have access to our camera escape. So camera dot main, so we're camera dot main, we're taking a reference to a main camera, and then screen point to ray, yeah, screen point to ray or screen point to wall, yeah, we need a screen point to ray, screen point to ray, and this will be simply our input mouse position. So mouse position. So yeah, that's our basic input. And then we are going to define a raycast hit like previously, and then we are going to check if physics.raycast hit out. Basically, if our raycast is hitting someplace in our terrain, then we are going to say selected object is going to be equal to hit.collider. So hit.GameObject. So whatever we are going to hit, it's going to have our collider. Basically can't hit anything other than collider. Only collider can give us data back, and after that we are basically saying like that game object equal to our select object. And if you don't know what collider is, let's just take a look at our UI. So if you can see in our like basic plane, we have the mesh collider, and that's mesh collider will have information about this entire game object. So from its transformation, position, rotation, material, everything. And that's what we are doing. And we got an actually error, so it's position, not POSITION. All right. What else do we need? So if selected game object, let's say because we are going to use tag here, so we can also get the reference to a tag here. So tag is equal to spawn. So if this tag is equal to this tag over here, that would mean that our selected game object name is going to be our transform name. So selected object name is equal to is going to be the object that we hit, its transformation, we are going to get it dot name. So it is going to hit the game object's collider. That collider will have information about its name, and we are basically taking that name, and then we can say like selected object dot get. Actually, wait, I'm just going to take this entire line because that's the only line that we need, and we can say like, so our selected game object is going to be blue. And the next thing we need is a delete system. So delete system is really easy since we already have a access to our game selected game object. All we can select input, actually yeah, input dot get key down, again just once, get key down, and key code is going to be delete. So if the delete key is hit while the object is selected, we just say destroy that game object. So selected object, that's all we have to do. You can play animation if you want. I'm not going to play any animation at the moment, like I don't think I need to, but that's up to you. So that's pretty much all we have to do with our game manager at the moment. Now let's go back to our drag manager, and sorry, drag game object. Now we can get a reference to our game manager GM. So yeah, we have a game manager. Now we need to create a awake method. Inside that awake method, let's say enable is equal to false. So when the game actually enables, it is going to set this script to false. We are also going to set the rotation script to false, and I'm going to explain that why in a short while. So gem is equal to find object of type, same thing as the last time, and the object we need is game manager. Now we don't actually need the update method now, so void on mouse down, on, let's say on mouse down. By the way, this is the actual method, not something I'm making up, so keep it the way it is. So on mouse down, what you want to do is basically see if the object or this script is actually enabled. To do that, you can basically say if this dot enable is equal to true. If this is enabled or this script is enabled, then go inside this script, and basically we need to get access to our C coordinates. So C coord is going to be equal to camera. I'm going to get an error dot, we are going to get a reference to our main camera, then world to screen. So basically whatever our world is, we are going to convert it to a two-dimensional script point. So world to screen point, and that will be our game object. Please no, yeah, game object dot transform dot position, and then we just need a Z position because we are going to be dragging the game object in our Z axis. Then m of Z is going to be equal to game object dot transform dot position. Did I misspell the transform? No, position. Game object transform dot position, and it's going to be minus our basically world position. So let's create a function called get mouse world position. Yeah, that's basically it. Now we do not have this method here at the moment, so let's quickly make it. So void vector3, now what do we need? We need to get our position, but we are taking it in vector3. So alright, let's just do vector3. The reason it's like highlighting in red because we haven't returned anything. So as soon as we return, it's going to go away, so don't worry about that. So m point is going to be equal to input dot our mouse position. So it's going to take our mouse position. Now m point dot z coordinate is going to be equal to z coordinate, and then we can just return our, what can we return, our camera may. So whatever this coordinate or m point coordinate is in z axis, we can basically reconvert that from like screen point to wall point. So that's what we're going to do. So return camera dot main dot screen to world point. Screen to world point, and just pass the m point. Yeah, and that's it. And sorry, the reason is I'm already saying it's a vector, so I no longer need to a void, so like it's conflicting it there. So yeah, now that we have access to this, and do we need anything else? I don't think so. So we have access to our world coordinate. Next thing we need to do is actually use the drag script. So on mouse drag, yeah. So on mouse drag is also a built-in method. So if game manager dot let's say selected object name. So our select object name is equal to game object dot name. So GameObject.name is going to refer to whichever GameObject this script is attached to, and game manager is basically which GameObject we click on. So that's why we are matching, like the GameObject that we're clicking on is equal to the GameObject this script is attached to. And if this dot encode is equal to true, again you need to check if this is equal to true. Basically if the script is true, then if game object dot tag is equal to spawn, so again we need to verify if our game object that this script is attached to, sorry, this script is attached to is or does have the tag spawn in it, then we can say game object. Wait, I actually don't need to write this, just copy this part, game object dot color, and we can say this is color green. And if the color is green, basically what we can say is if this is enabled, uh, sorry, yeah, if this is enabled and the color is green, we can say transform dot position. Transform dot position is equal to, so we are going to transform to get mouse to wall position plus m offset. That's it. That's all we have to do. One more thing we need to do, and that is very important, and that is to we have to like let the color revert to white or whichever default color, because if we don't use mouse up, then it is going to stay green forever. So not forever, but yeah, for a quite while. So for that, just do like mouse up. So on mouse up, just do this method, and here just take this same line, so it really doesn't matter, just take this line and basically paste it. So game over the mouse render, and we can say white. Alright, so yeah, that's looking really good. Basically it's not, copy this in the rotate, paste it, and what else do we need? So basically, yeah, that's pretty much it, I guess. The rotation script is going to be fairly simple. So similarly, private, what? Private. Yeah, private float. We're going to use floating value, and we are going to use rotation. Speed is equal to 2.5 f. You can give whichever number you want. I'm just randomly throwing a number. And then game manager GM, and basically like take this, like actually you can take, because both of this will be needed, and yeah, copy this, paste it here, done. So at the start this script will also be disabled. We are going to take reference to our game manager, then we are going to take our mouse down. So basically whichever, like whatever we're doing, we're taking a mouse down. Actually no, because we're going to be just dragging, we don't need the mouse down. On mouse up, we can basically say like, yeah, it's going to go back to white again. Yeah, that's pretty much it. Now we don't need the update method. What we do need is the on mouse drag method. So on mouse drag method, and here if we can just do like if game dot select object name is equal to game object dot name, it is going to give us this. Low, come on. And what we can say, like if this is this dot do is equal to true. So if the script is enabled, we can basically say if our game object dot tag equal to spawn. If our game object tag is equal to spawn, again similar to what we did here, the only difference is going to be is if a tag is equal to spawn. Oh yeah, you have to put it in curly double parenthesis, not single. Okay, if the game object is equal to spawn, we're going to say it is going to be red. And what else? We can basically say float. So x rotation. So we can say x rot is going to be input dot get axis. This is going to take our mouse x. So it's going to take a mouse x axis, and we're going to multiply this with our rotation speed. Take this entire line, copy it, paste it here, y axis. Yeah, that's pretty much it. Then transform dot rotate, and we are going to rotate it in vector 3 dot down. Numeric is going to auto input, so remove that. Vector dot down, and it's going to be x rotation. Now copy this entire line and paste it. So rotate, it is going to be right axis, so right, and it is going to be y. That's it. So that's pretty much all we had to do for both drag and rotate game script. So now let's actually implement all those. We have an error in our game manager in 68 number line. So game manager 68, we have electric object, no selected object. So it's pretty much done. Now let's create a prefab folder. We can call it prefabs. Inside the prefabs, we can basically create a at first save this. So save as main. So let's going to save this script as main. Here we're going to where is game object cube. I'm going to move the cube a bit up. That's why we have this y position. That's where adding with our instantiation. I'm going to scale it to 0.4, 0.4, 0.4 to whatever you want. Okay, let's go to the cube. It looks nice. It's on the ground very well. Yeah, so cube is going to be cube. And by the way, are you using small or big? Small or big? Okay, so object to instantiate is going to be equal to cube. That's nice. So no problem there. But just to be sure, actually no, it's fine. It's fine. Similarly, I'm going to instantiate a sphere. Again, I'm going to give its position scale 0.4, 0.4, so our sphere is also 0.4, and as you can see, it has a collider as well. So that's pretty much all there is to it. Let's just actually I'm going to place it inside and reset its value. Now just drag it outside and come. So we have our prefab and our sphere. Now attach the drag script to both of them. So Where did we? Okay, just here is the drag script and here is the rotate script. Now go to cube, then tags, then click add tag and add a new tag for spawn, because our game object is expected to have a tag called spawn tag. Alright, do the same, spawn and script. For cube we already added drag and rotate. For sphere also add drag and rotate. So drag and rotate. Nice. Now drag cube here and sphere here inside of prefab folder and delete it from here. We no longer need it because we have a reference here. Okay, that's done. Now let's create a new basically we can call it a spawn manager. Spawn manager. Spawn manager and a game manager. Now game manager, yeah. So add the game manager script to our game manager and add the spawn manager script to our spawn manager. Now in the spawn manager what you have to do is place these two prefab. So in the cube place the cube prefab, in the sphere place the sphere prefab. In our game manager what you have to do is drag and rotate, and you have to also drag the spawn game object manager. So that's what you have to drag it. And anything else we have to do? No. Now in our cube, remember that we made a script to basically check like what we're actually spawning. So if we go here, you can see like what we're actually trying to spawn, and that's because of this method on clicked. So cube, add a new method, spawn manager is going to drag it here, and you are going to go to spawn manager and on clicked, and it's expecting a game object. So just drag the cube basically button here. Similarly go to sphere, add the spawn manager here, is going to expect a game object on clicked function. So just drag the sphere here. That's it. Now let's play the game. Now I'm going to click the cube. I'm going to click anywhere in the map, and if I hit R, it's in rotate mode. So here I can rotate it however I want. If I hit R again, it's in drag mode and I can drag it wherever I want. Similarly with sphere, if I hit the R, it's in rotate mode, and if I hit R again, it's in drag mode. Alright, so we can instantiate our cube, we can instantiate our sphere, and we can rotate it and drag it. Now the last step of this tutorial, it's going to be basically we are going to have to create a complex but yet really simple save system. And to do that, we basically need to make one extra script, and that script is going to be a save manager script. So save manager or save system, that's all you have to do. So nothing more, nothing too fancy. Open that app, and basically here, so yeah, in our save system, the first thing we need to do is get a reference to our system.io, because Unity is built in all save system or save system related functions are stored in the IO function. We do not need the update and this method. We also do not need the mono behavior, because this is going to be public static class, not just a normal class, because you understand it very soon. Next we need to make a public static method, and it is going to be read only. The reason it's going to be read only is because we do not need to change it. It is going to be just for the path alone. So save directory. What did it import? Okay, it didn't import anything, and it is going to be application.datapath. Application.data application.datapath, and the application datapath is basically going to be whatever path or directory you want to save your data. So for me, you can basically, if you want, you can save the data to like persistent path. Like persistent path is basically going to be app data. If you go here, it's going to be in local, and it is going to be default company and whatever game you're making. So this is called a persistent path, but for this tutorial purpose, I'm not going to be saving it to persistent path. I'm basically going to saving to a basic directory inside our project. So let's say it's going to be saved here. So that's why I'm just going to say saves, and that's it. Now, what do I have to do? We need a like file extension type. So normally when you're making a game, you never use JSON file, and you're obviously going to encrypt all this data. Like obviously you don't want everyone to see your data, but for me, this is a tutorial, and I'm not going to go too over the encryption method, because you can use any encryption you want. You can use MD5, you can use SRF, you can use SH1 or SH2. That's up to you. So let's just say private const, and string is going to be save extension, and I'm going to save it in JSON, but in real game never save in JSON. This is the easiest to hack. Okay, what else? We need a public static void. So public static void init method, and this init method is basically going to be responsible for creating our directory as well as loading our data. So I'll say what I mean really quick. So if directory doesn't exist, so if our directory doesn't exist, it's going to create the directory. So if the directory doesn't exist, directory dot create directory, and the directory we want to create is the save directory. That's it. A really easy line, but that's going to be responsible for creating a directory. Next, you want to create a public static method. So public static void, and it is going to be save. It is going to take a string value. So the string value, you can give it whatever name. I'm going to just say save data. Now, this is a very important thing. So basically, like, you can have a game where you only have one save data. So basically like one save file, and you continue to rewrite that save file every time, update it, delete from it. Or if you are creating a modern game and you want to like give the user a option to like load different save file, let's say you have 10 save file and the user can load like different save file from different period of time, then this is the route you want to go. So let's say for this tutorial, I'm going to show you like how to create a different save file. So what you want to do is int like save number. All right, very easy. What the save number. So our initial save number is 1. So basically at initialize we start with number 1. So file dot exists. If the file already exists, save directory plus we can say save under slash. So basically like this format right here, or you can give whatever format you prefer, plus number. So save number. Then we need extension. So for that I'm going to do this, or if you want, like you don't want to go to all this trouble, just remove this, add extension right here. All right, You can do it right here, no problem, but for me I'm just going to do it like this again, and then save extension. Where is the save extension? Here is the save extension. So if it already has, or sorry, if the save exists, it's going to increase the number. So if the save increase or already exists in the directory, then it's going to increase the number of save file to 1. But if it doesn't exist, so file dot write all text. You do not want to use all line. Basically, you do not want to use all line. You want to use all text, because that's the best way to basically like completely rewrite the file rather than like writing it line by line. And then you have to go to save directory and basically all this line. So save directory, you are saving everything, and what you are actually saving is the save data. That's it. And that's the entire line. But there is a little bonus. If you don't want to go through all this trouble, if you just want to save in one single file, then instead of save number, like you basically do not need this. Instead of save number, what you can do is like keep whatever file name you want. Let's say save, and it's going to continue to rewrite this one file. So in that case, you do not need all this line, like basically comment it out and just have this one line active. So it's going to continue to rewrite this one file. So that's the save method. Now we are going to work on the load method. So load method is also going to be simple. It's going to public static type of string, and it's going to say load. Now load method isn't actually going to take any data, but rather it's going to return a data. So directory info, just take it, directory info. If it's equal to new directory info, and the directory we want is the save directory. Now we need to say like file info, and it's going to be an array type because we're going to read all the save files. The save files we're going to be basically getting from the directory info dot get files, and we're going to put the star or asterisk. I really don't know what this is actually properly called. I call it a star, and then plus the save extension. Save extension. So what this is going to do is going to it is going to find all the files with the extension JSON. For your case, it can be like not JSON, but let's say TXT or like BAT or like custom like DND, doesn't matter. So whatever extension you have, it is going to go over the entire directory to find all the file with that extension. And after it does, what you are going to do is file info. Then you want to search the most recent file. So most file, or you can just do recent file, like you don't need to go all that. Recent file, and the recent file can basically be initialized as null because you are not like finding any new file. And then we are going to run a basic loop, like we are already taking all the save files here. So for each loop or for loop, whichever you prefer, and then the system type is going to be file info. It's going to be file info info, not in for, info in our save files, and all the save file if the most recent file is equal to none. Basically, if a actual recent file, so if a recent file is equal to null, then what we can do is make the recent file equal to file info. So our first file, or the first file in the loop, is going to be the recent file. else if file info dot last write time. So what we need to do is get the file that we last written, and if it's greater than recent file dot last write time. So if it's greater than the recent file's last write time, so let's say if 3's time is greater than 2, then basically 3 actually 2's time is greater than 3, then basically 3 is a new file. So that's what we're saying. And so basically if our last file is like basically greater, so 2 is greater than 3, then we can select recent file is equal to file info. So we have taken the file, but we haven't actually read the file. So in order to read the file, what you have to do is get out of this loop and basically say if like recent file is equal to null, then just like you can throw an error or give something. And if it's not null, basically if it's not null, then just take a string called like say string. What can we do inside a save string? So inside a save string we can do like file.read. So we are going to be reading all the text inside the file, and which file we are going to be taking the recent file, and we need to read the full name. So yeah, so the reason we need to read the full name is because up until now we're just like comparing, taking the name of just the JSON, but now we need to take the full name. So the full name is save_2 or save_3.json. That's why I need to read the full name, and we need to return it. So return save string, and else just return null. So we don't have any data, make new data. That's all we have to do for our save system. Now let's go back to our game manager, and this is where we're going to handle the most of the logic. So to handle most of the logic, first thing we need to do is create a method at the bottom. So at the bottom, let us create a system serializable. Okay, it actually gave me suggestion. Nice. Okay, public struct. We need a structure type, and then what we need to, we can give it any name we want, but for me I'm going to say like save game object. All right, and that's what structure is going to have a public method called list, because let me just quickly show you the difference between list and normal. If we say list, it is going to create an array, and inside that array it is going to have multiple like dictionary type value. But if we don't create a list, then it is just going to create the dictionary value, but we won't be able to use it as an array, so that there will be no like separation. All right, that's why we're using list. So public list, the list type is going to be data that we haven't created it, and we can basically call it data. So let's create the data type. I can copy this, system serializable data, and here we are going to basically take the name, string name, string position, not a string, it's going to be vector, so 3 position, and we need a rotation. So public we need rotation, and the reason we are doing rotation like this, I'm going to explain. Unlike position, so if we go here, it's going to give us an error, no problem. Let's say take this cube, you can easily take this position value whenever you want, but the rotation value is a bit complex to get it. So that's why we are going to take the rotation value, and we are going to basically convert it to float for our test case. But position, If you just take the vector of this transform, you can get the position x, y, z. Rotation is a bit complex, so that's why we are making another struct for rotation. Copy it, paste it here. It is going to be rotation. Make sure the naming matches, and here I'm just going to say public float x. Copy. And this is going to be y, and this is going to be sorry, this is going to be z. Now that we have made our struct, we have to declare a save method, because we haven't actually made any save function yet. So we have to create the save function right now. So to make the save function, make a private function, private void save. Okay. Now we can basically get a reference to our save game object which we created earlier. So save game objects, and here we're going to say save data is equal to new save game objects. Now what we can do, we can say like save data dot data. We are basically initializing it, and new list data. So right now we just initialize this array, but we haven't put anything inside the array. To put in data inside the array, let's go here. Let's say spawned game object. Yes, we need to take spawned game objects, and it's going to be equal to, but actually no, it is going to be spawned objects. Do we have a method for spawned objects? I don't think so. I think, do we have a method for spawned objects? We have method for spawn game objects. I think we never made a method for spawned objects. Yeah, we made it a spawned game object. Okay, so no issue. We can basically call it spawned objects. This spawn object is going to be game object. I'm going to click here, then find game objects with tag. So game find game objects, objects with tag. If you don't put the s here, if you just say find game object with tag, it is going to get only one game object. But if you put the s, it is going to get all the game objects with that tag. All right, a simple thing to basically mistake. And because we are using array, it is going to take all the spawn game objects tag or the game objects with the spawn tag and put it in spawn game object. After that, we can basically say like for each loop again, and it is going to take game object. Okay, so game object is spawned object or spawn here. So all the game objects in spawn game object is going to take it, and we're going to take the vector tree of all the game objects, and let's say, what can I say, like game object position. So whatever our game object is, its position is going to be saved in game object position, and basically say spawned object dot transform dot position. Now taking the position is way easier than taking the rotation. So now let's work on the rotation. Float rot x. So basically we are going to take the x rotation, define it as a variable called rot x, or you can name whatever you want. And if uh, spawn GameObject dot transform dot Euler angle dot x is less than or equal to 180 degree. If it's less than or equal to 180 degree, then rot x is basically going to be equal to this. Else it is going to be equal to this minus 360 degree. And now this I did not come up with it. I actually saw it in a post in Unity form. So if I go here, take like get object, I think, yeah, this post right here, I think. So the credit actually goes to this guy for finding out. This is a really nice way to get the rotation, and that's what we are using right now. So we are taking the rotation x. Similarly, we are going to do this for the y rotation as well. So rot x is obviously going to be rot y. Instead of x, it's going to be y angle. And once again for the z rotation. Again, do read this. This is a really well made code here. So we got a rotation. Sorry. Now what do we need to do? We need to add this in our data. So data is equal to let's say new data. We just insert this right here, data. Now inside our data dot name is going to be equal to spawn object or spawn GameObject dot name, and the position data dot position is going to be equal to our GameObject position, and then we need to do our rotation. So rotation we need to like initialize. So rotation is equal to like rot for rotation, and then rotation. Now that we have our rotation, what you need to do is put the value individually. So for x, it's going to be rot x. Take it, copy it, paste it 2 times. It's going to be y, capital Y, and it's going to be z, capital Z. Now that we have all that, we can say like data dot rotation is equal to rot. After that, up until now you have added the data, but you have not added it into the array. So in order to add the data to array, what we have to do is call save data dot data. Remember, we haven't actually added the data here. Up until now we have added the data right here, but this is an array. So for that we need to do add and basically add the data. So underscore data. Now we have added the data to array. So that's how we did that. Alright. Basically we initialized this struct, but we haven't added the data in the array. So now the data has been added to the array. All we have to do is string let's say json, and json utility dot to json, and to json is basically going to be save data. Do we need anything else? No. So basically call save system dot save, and it's going to take the JSON. Now we should be able to save it and quickly check that if we can save the data. We can basically save on application quit. So on application quit, we can say save. Pretty easy. And actually let's create the load method as well. Like load method is very simple. So private write load. So on the load method, first thing we need to do is string our save data is going to be equal to save system.load. So remember that from our save system, we are basically returning a string that has data about our recent save. So if let's say 1 is a recent save, it's sending all this data. Now what do we need to do? Actually, let's keep that open. We'll need it. If save data is not equal to null, basically our save data is not null or is actually populated, then save game objects. So our save game object is going to be save game objects equal to JSON utility dot from JSON. I think, yeah, actually is it from JSON or JSON to text? Oh no, it's from JSON. So it's going to be from JSON and it's going to be save game objects. Now it is going to be save game object because that's the game object we're saving it, and then the data. So that's again like this has reference here and this has reference here. So basically we just need to call it at the top level. That's pretty simple. Now let's run a for loop. You can run for each if you want. For me, I'm going to just do a for loop for I is equal to 0, like we always do. I is less than saved game objects dot basically data dot count, and the reason is I'm going to explain right now. I plus plus. This is one data in the array. So if I minimize it, there are 3 data in array. This is one data, this is one data, this is one data. That's why I'm saving. I'm actually getting the count of data. So data is an array. You can have like multiple arrays for one. So like multiple arrays, and each array could have different name. Like this could be like health. This could be like stats. So you can have multiple different array, and to basically get the data from the array, call the array name and then count it. So that's why I said data dot count. All right. Now you're going to do game object. This is going to give an error. So I'm click here, spawn object or spawn game object. I like this one. Actually instantiate, we're going to instantiate, and we're going to instantiate the spawn. Actually wait, there's a bit error I think, because first of all like which object, we don't know which object we are going to instantiate, because we could instantiate the normal game object, but we also could instantiate the like cube or different prefab. So first of all, look, wait, what did I call it? Spawn game objects. Spawn game object dot, we don't know if this is going to be the cube prefab or the sphere prefab, so we have to do something about it. So game save GameObjects dot data plus inside the ISO the first data, then its position. So we are getting its position, then Quaternion dot identity. We're taking its identity because you can't actually set the rotation on this line, because sometimes it actually gives a bug, the rotation is off. So I think it's better to like make the rotation on a separate line, but if you want you can also add the rotation on this line as well. Not much, just extra one line. So it's font game object dot name is going to be equal to the save data dot name, save data dot name basically, and rotation. Now this tricky part. So font game object dot transform dot rotate, rotation. Transform dot rotation, you can't use the rotate keyword, you have to use the rotation keyword. And Quaternion dot Euler, and here we are going to say game data dot rotation dot x. So we are taking the x rotation, we are taking the y rotation, and we are taking the z rotation. Okay, I think that's pretty much it, but there is a one big issue. We do not know which game object to call. We are just basically calling qprefab. So basically to fix that, we can select if we can select save game objects dot data dot name dot to string. So we are going to cast it to string, then contains. If it contains like cube, so yeah, it's, oh yeah, it is going to contain small cube because we didn't change anything. And in that case we can say it like that, indent. And if it's not cube but else, if it contains sphere, then just load the sphere prefab. That's the only change we have to make, nothing else. And that's pretty much it. Like our save system is really I think ready for testing, and the only thing I think we do need to do is initialize it. So before the start method, call a awake method, so it's going to awake and save system dot init. Because if we don't call the init before in awake method, then it won't create a extra directory inside our save folder. So that's why we are creating or calling the init in the awake method and not a start method, and then just hit load. That's it. Okay, that looks pretty well. Let's try it. Okay, there is an error, and I'm pretty sure it's a numeric error. Yes, it's a numeric error. Nice. It's going to be ambiguous, no problem. Keep an eye on here. If once we play, we're going to add a game object, hit R to rotate mode, we're rotating it, sphere, R to like in drag mode, let's drag it here, another cube here in rotation mode and in drag mode, and let's quit out. Now let's see if we get our save folder. So let's play it again, and we have our game object exactly where we left it. So now let's take this game object. I'm going to hit R for drag mode, bring it like over here, and I'm going to take this like sphere in drag mode. I'm going to place it right here. Alright, now quit out and if we go and play it again, see, it's saving it right there, so it's working really well. And if we just check here, it's saving two basically different file. And if we delete one, let's say we delete the sphere and we quit out, if we go back, we are going to see that it has also been deleted. So yeah, that's pretty much it for this tutorial. And one more thing, actually, we actually have to create a button for basically exit. So save, I'm going to call it save and exit. All right, very simple. Go to 2D mode, okay, click on the button, position, I'm going to center it to the top right, so hit Alt and top corner. That's it. Pretty simple. Give it whatever color you want. Let's give it a nice purple color like Satoru Gojo's Hollow Purple. And yeah, that's pretty much it. Actually, let's make it aggressive purple. And then for the text, we can basically have a white. Now I'm going to create a simple method called save method, just for like saving the data. So save and quit is basically going to be a simple method. So let's say public void save quit. All right, simple method. It is going to save it first, and once it's saved, it's going to say application dot quit. That's it, application dot quit. Now I'm going to go back here, take the game manager, save, go here, add component, take game manager and select the function save quit. Now if I go back here in the build setting, add the current scene and basically build and run, I'm going to call it directory called build. Inside build directory, I'm going to run it. Let's see. So we have our game with free rotation. We can instantiate a game object, hit R to enter rotate mode. We're in rotate mode, hit R to like drag mode, another cube, rotate mode, a sphere, drag mode, another sphere, drag mode, another cube in rotate mode. What else? So 7 exit. Now if I basically go to show in Explorer, I can say save system build, then run the save system again. See, we have all our object. Let's click that. Let's go to drag mode. Let's keep it here. And as for this object, we are going to hit the delete key. It's going to get deleted. Save and exit. Save system again. It saved the position. This object has been deleted. So yeah, it's working really well. I'm really happy with that. And yeah, that's pretty much it for this video. Hope it came in handy. And one more thing, like you should never create a save system like this, like not a regular JSON file. You should always encrypt it, but for the purpose of a simple video like this, I didn't encrypt it. So hope that helps you, and till next time, bye.